Hey there, knowledge seeker. You ready to dive into some pretty cool AI research? I
Always.
think you'll like this one. Today today's deep dive is focused on LLMs.
Large language models.
Yeah, those
Yeah.
powerful AI systems, the
Yeah.
ones that can generate text and answer questions and write code and all that.
Yeah, really impressive stuff.
It is. And we're looking at, the main source material is this paper called Row 1. Not all tokens are what you need.
Catchy title, right?
It is. It really is. It kind of hints at like well, a whole different way of thinking about how we train these big AI systems.
Yeah, it really gets at like the heart of the issue. We
Mhm.
always think more data equals better results with AI.
Right.
But this research is kind of like, whoa, hold on a second.
It throws a wrench in there.
Yeah.
Okay, so to set the stage, maybe we should do a super quick recap of what LLMs even are.
Yeah.
I always like to think of them as like incredibly powerful prediction machines.
Hmm.
They just devour tons and tons and tons of text data, and they learn these really intricate patterns, like relationships between words. And then they can generate human quality text, sometimes even better than human.
And more. Don't forget all the other things.
And more. Yeah, it's crazy.
And traditionally, we've trained them by basically making them predict every single word in the data we give them.
Right, every single one.
But the question is, what if instead of treating all those little bits of information as equally valuable, we could teach the LLMs to be more selective?
Ooh, interesting. That's where this row 1 comes in, right?
Exactly.
So it's like instead of just force-feeding the model all this information, this new approach is like, hey, let's focus on the good stuff.
It's all about efficiency.
Yeah,
Why waste time on things that might not be so important?
right.
Like imagine you were trying to learn a new language and you just sat down and read the dictionary cover to cover. You'd be bogged down with tons of words you might never even use.
Oh, for sure.
It's much more efficient to focus on the words and phrases that are relevant to what you want to do. Row 1 brings that same idea to AI training.
So it's like, are we giving the LLM a super smart study guide to highlight the key concepts it needs to master?
Exactly. And the results are they're amazing. They found that Row 1, trained using this selective approach, totally outperformed traditional models on math tasks, even when it was trained on way less data.
Hold on, wait. So you're saying they got better results with less data? That's wild.
It is kind of counterintuitive, right? We're so used to the idea that bigger is always better in AI, but Row 1 is like, nope, sometimes less is more.
Okay, I'm definitely hooked. Now let's break down how they did this. I know they mentioned something called Selective Language Modeling, or SLM.
Yeah, SLM, that's the heart of it. It's all about training the LLM on the most useful tokens.
Okay, so remind me, what's a token again?
Oh, right, sorry. A token is basically like a chunk of text, like a word or a punctuation mark.
Okay, got it. So it's not about getting rid of data entirely, but picking and choosing which pieces the LLM should really focus on during training.
Exactly. The trick is figuring out what makes a token useful.
How do they do that?
They train another model. They call it a reference model.
Oh, interesting.
And they train it on a super curated, high-quality data set.
Right.
And that model kind of acts as a guide. It helps identify the tokens that are really aligned with whatever it is they're trying to teach the LLM.
So it's like having a seasoned chef teach a culinary student which ingredients are crucial for a specific dish.
Haha, yeah, perfect analogy. And it works. The results are amazing. They found that by zeroing in on these high-value tokens, Row 1 could perform just as well as a model that was trained on a data set that was 30 times bigger.
30 times. That's incredible. Talk about efficiency.
Yeah.
But they didn't just test this on math problems, did they?
Nope, they also tested it on some more general tasks.
Yeah.
Still saw improvements, especially in things related to code and math.
So this approach, it could totally change how we train LLMs, right?
Oh yeah, for sure. Make them faster, smarter, and much more efficient learners.
I mean, if Row 1 can learn math that much faster by focusing on the right data, could we apply this to other things? Could we train LLMs to be experts in, like, medicine or law or, I don't know, even art, by being super picky about what we feed them?
That is the million-dollar question.
It's a good one.
And that's exactly what we're going to be exploring in the next part of our deep dive. We'll go deeper into how Row 1 could actually be used and what it could mean for AI in general.
Ooh, I'm excited. But before we get ahead of ourselves, let's break down exactly how this selective learning works. I know they mentioned something called token loss, which sounds kind of mysterious.
Yeah, token loss, it's not as complicated as it sounds.
Okay, good.
Basically, it measures how well the LLM understands a particular token during training.
So the lower the loss, the better the understanding.
You got it. And what's interesting is they looked at how this token loss changes over the whole training process, and they found some pretty interesting stuff.
Oh, yeah, they, like, categorize the tokens, right,
Yeah.
based on how their loss changes over time.
Exactly. There are four main categories: tokens with persistently high loss, tokens with increasing loss, tokens with decreasing loss, and tokens with consistently low loss. And they found that only a small percentage of the tokens actually show a really big drop in loss during training.
So most of the tokens are either already learned or just not that important for the LLM to really understand the big picture.
Yeah, pretty much. And get this, they saw that a bunch of tokens, even the ones with low loss, actually fluctuate a lot during training. Like they never really settle down.
So just bouncing all over the place, making it harder for the model to learn efficiently.
Exactly. That's where SLM comes in. By just focusing on tokens with high excess loss, basically the difference between the current model's loss and the reference model's loss, they can target the tokens that are most valuable to learn at that point in time.
So it's like a dynamic process, always adjusting to what the LLM needs most at any given moment.
Exactly.
Okay, hold on. How do they even measure that excess loss?
Well, first, you got to train that reference model on that high-quality data set. That sets the bar. Then they use the reference model to look at the loss of each token in the larger, the pre-training corpus.
So they're comparing how well the LLM understands a token to how well the reference model understands it. And the bigger the difference, the more that token needs attention.
Yeah, that's the basic idea. They even have this thing called a token selection ratio, which determines how many tokens they'll actually use for training based on this excess loss. And they found that picking about 60–70% of the original tokens gave the best results.
So they're filtering out the noise and focusing on the important stuff. But do they completely ignore the rest of the tokens? Like just throw them away?
Not really. They still use the whole sequence, but they only apply the loss function, the thing that drives the learning to the selected tokens.
So the other tokens are still there, but the LLM isn't actively trying to learn from them.
You got it. Imagine you're reading a textbook and you highlight the really important parts, but the rest of the book is still there if you need it.
I like that analogy.
And remember, this whole selection thing, it's dynamic. So as the LLM learns, what makes a token useful also changes.
It's like a continuous feedback loop, constantly fine-tuning what the LLM should be paying attention to. Wow, this is really cool. It's all starting to click for me now.
Awesome. Well, that wraps up part 1 of our deep dive.
Already, we covered a lot of ground.
Yeah.
We went over the idea behind selective language modeling, talked about token loss and how it changes during training,
And in part 2, we'll get to the really exciting stuff, how we can actually use all this. What does it mean for the future of LLMs? What kind of applications are we going to see? How might it change how we interact with AI every day?
Okay, I'm on the edge of my seat.
All right, welcome back. Ready to explore what all this could mean in the real world.
Oh, I am. I'm still kind of wrapping my head around the idea that focusing on less data can actually lead to better results. It's like the LLM is becoming a way more discerning student, figuring out how to prioritize the really important stuff.
It's a good way to think about it, and that's why so many people are excited about this research. It's like it opens up so many possibilities.
Okay, so let's get into those possibilities. What kind of practical applications could we see coming out of this selective learning approach?
Well, the potential's huge. Imagine LLMs that are like specialists, experts in specific fields like medicine or law or finance.
So like an AI doctor that can, I don't know, analyze your symptoms and suggest possible diagnoses, or an AI lawyer that helps you understand those crazy legal documents.
Exactly. Or think about education. We could have these personalized AI tutors, ones that adapt to each student's needs and learning style.
Oh, wow. That would be a game changer for sure. It'd be like having a private tutor available 24/7 who's always adjusting to your progress and helping you with the things you're struggling with.
And it's not just about making existing applications better. SLM could open up whole new possibilities too.
Like what? Give me some examples.
Okay, well, imagine an LLM that can analyze all that complex scientific data out there and help researchers make, groundbreaking discoveries. Or an LLM that can translate languages super accurately, breaking down those barriers between cultures.
It's like we're giving AI the tools to tackle some of the world's biggest problems.
And even on a more personal level, imagine LLMs that understand your preferences, what you like and don't like, and can create these super personalized experiences.
Yeah.
Whether it's recommending books you'd love, planning trips, or even, I don't know, composing music that matches your taste.
Okay, I'm getting really excited now. It sounds like this tech could affect just about every part of our lives.
Yeah, the potential is huge. But let's not get too carried away just yet. It's still early days for this research.
Right, they do acknowledge that there are some limitations,
Hmm.
some challenges to address.
Exactly. Like one of the big questions is, can this approach really work with those supermassive LLMs and data sets that are becoming more and more common?
So while it shows promise on smaller models, we don't know for sure if it'll scale up smoothly.
Right. More research is needed to see how well SLM performs at that scale.
And they mostly focused on math and code stuff, right?
Yeah,
So we got to see how well it works in other areas too.
totally. We need to explore how effective SLM is for things like language understanding, reasoning, creative writing, all that stuff.
So it's got to be more than just a math whiz.
Exactly. And another challenge is, making sure the whole token selection process doesn't accidentally introduce bias.
Oh, that's super important. If we're being picky about what an LLM learns, we got to be really careful not to skew its understanding of the world. You know what I mean?
Exactly. The researchers know about this concern, and they suggest exploring different ways to measure token importance so that bias is less of an issue.
So we got to make sure the LLM study guide isn't biased towards certain perspectives or types of information, right?
Great way to put it. It's all about balance, selectivity, and fairness.
It's like a reminder that as we build these super powerful AI systems, we have to think about the ethics, the implications. It's not just about, technical advancements, but also about making sure these technologies are used responsibly for the benefit of everyone.
Couldn't agree more. And the researchers themselves say that ongoing ethical evaluation and discussion are super important.
We need to constantly be talking about the impact of this tech, and making sure it lines up with our values.
Totally. But let's change gears a little and dive into one of the really cool things they found is this double descent phenomenon with token loss.
Oh yeah, you mentioned that earlier, and I was definitely intrigued. Sounds kind of sci-fi, doesn't it?
It does have a little bit of a mysterious vibe, yeah. But it's a pretty fascinating insight into how these LLMs learn.
So remind me, what exactly is double descent?
Okay, so basically, it's the observation that during training, the perplexity, you could think of it as confusion, of the LLM about certain tokens can actually go up at first before eventually going down.
So it's like the model gets more confused by the very things it's supposed to be focusing on before it finally starts to understand them.
Exactly. Seems kind of counterintuitive, but they think it might be a natural part of how SLM works.
Okay, how so?
Well, remember, SLM is always zeroing in on the most challenging tokens at any given point in training. So as the LLM's trying to wrap its head around these tough concepts, its initial perplexity might actually increase.
It's like it's being pushed outside its comfort zone.
Yeah.
Forced to confront the things it doesn't get yet.
Perfect analogy. And then as the LM wrestles with these challenges and the model adapts, the perplexity gradually decreases, and that's what leads to better performance.
Okay, I'm seeing the logic now. It's like they're saying no pain, no gain. Sometimes you got to struggle a bit to really learn and grow.
Exactly. And this finding really highlights how important it is to embrace challenges in the learning process, both for AI systems and for us humans.
It's a good reminder that learning isn't always this smooth upward climb. Sometimes we need those moments of confusion, those struggles, because they can help us understand things more deeply in the end.
Well said. But let's shift focus a bit and look at another interesting part of this research. The analysis of the types of tokens that were selected during training.
Oh, right. They found some interesting patterns there, didn't they? Like certain types of tokens being favored at different stages of the learning process.
Exactly. What they saw was that the tokens selected by SLM often fell into these clusters that kind of reflected the LLM's evolving understanding of the data.
So it's like the LLM is building up its knowledge base in a systematic way, starting with the foundational stuff, and then gradually expanding to include more complex concepts.
That's a great way to picture it. It's similar to how humans learn. We start with the basics like grammar and vocabulary, and then we build on that foundation as we learn more and more.
It's like learning to read. You start with the alphabet, then simple words, then sentences, and eventually you're reading novels.
Exactly. And this gradual progression seems to be super important for learning, both for AI and for people.
It's all about mastering the basics first, and then expanding from there.
And this research gives us a glimpse into those intricate processes that drive how LLMs learn.
It's like we're looking into the mind of an AI, seeing how it learns and grows in real time.
And one of the most encouraging things they found is that even a relatively small reference model, one that's trained on a limited data set, can still effectively guide the learning of a much bigger model.
That's what they called weak to strong generalization, right?
Yeah.
It's surprising that a small model can have such a big impact.
It is, but it highlights something really important. Effective guidance isn't necessarily about size or computational power. It's more about pinpointing the most valuable information within that training data and making it stand out.
So even a smaller model, if it's trained on good data and focused on the right things, can be a great teacher.
Exactly. And this is exciting because it has implications for making AI more accessible, more scalable. We might not always need these massive, super expensive reference models to make this selective learning thing work.
So we could apply this to way more tasks, more areas, even if we don't have a ton of resources.
Exactly. It opens up a ton of possibilities.
All right, so we've talked about the potential applications, the challenges, that weird double descent thing, and even how LLMs seem to build their knowledge kind of like humans do. This is all pretty mind-blowing.
And we're not done yet. We still need to talk about how SLM could work even without a separate curated data set.
Oh, right, the self-referencing approach.
Yeah,
That's where they trained the reference model on a subset of the main training data itself.
that's it. It might sound kind of circular, but it actually works pretty well.
So even without that perfect reference data set, this selective learning thing can still make a difference.
Exactly. It shows you how powerful it is to be deliberate about what you're learning from. The key to SLM success isn't necessarily about having a perfectly matching data set. It's more about getting rid of those noisy, irrelevant tokens.
So even an imperfect guide can still help the LLM stay on track.
Precisely. And that's why this finding is so encouraging. It means that even with limited resources, we can still use this approach and see benefits.
It makes the technology way more accessible, more widely applicable.
Exactly. But I think it's time to step back and look at the bigger picture, you know?
I'm ready for that. This research has really got me thinking. What does this all mean for the future of AI and how we interact with these systems as they get smarter and smarter?
Well, I think it shows us that the future of AI isn't set in stone. It's being shaped right now by the choices we make, the questions we ask, and what we do with this technology.
That's empowering. So big picture, what do you think this research means for AI?
I think it paints a pretty optimistic picture. It suggests that we can create AI systems that are not only more powerful and efficient, but also more in line with what we want, our values and goals.
It's like we're moving beyond AI as just a tool toward a future where AI is a real partner, helping us solve problems and pushing human knowledge forward.
Exactly. And that partnership starts with understanding how these systems learn and how we can guide them to get the outcomes we want.
That's what I find so fascinating about this research. It's not just about the technical stuff, it's about those bigger questions, about intelligence, learning, and what our relationship with AI will be.
And speaking of questions, I think it's time to turn the tables and ask you, our knowledge seeker, for your thoughts.
Great idea. We've covered a lot of ground today. We talked about the basics of selective language modeling, looked at how it could be used, the challenges, the ethical stuff. But now we want to hear from you.
What are your takeaways? What excited you the most? What are you still wondering about?
And what do you think AI will look like in the future?
Do you think it can help us make the world a better place? Or are there risks that worry you?
We think open, honest conversations about AI are super important.
So let's hear from you. What are your hopes and feels about AI? What role do you think selective learning will play in all this?
And we're back. For the final part of our deep dive into row one and this whole idea of selective learning for LLMs. Man, we've covered so much ground, from like the nitty-gritty details of how it works to like the mind-blowing potential this has.
It's been a wild ride, hasn't it? I really feel like we've only just scratched the surface of what this tech could do.
I totally agree. And now, like we promised, it's your turn. Time to hear from you, our amazing knowledge seeker out there.
Yeah, we want to hear your reactions, your thoughts, everything.
What really stood out to you during this whole deep dive? Was anything like a total surprise?
Yeah, what questions are still bouncing around in your head?
And maybe the biggest question of all, how do you see this technology shaping the future? Like, what's your vision?
Do you think AI can solve big problems, make life better? Or are you more worried about the potential downsides?
You know, we really believe that these open, honest conversations about AI are so crucial. It's the only way we can figure this stuff out together.
So come on, let's hear it. What are your hopes and fears about AI? Where does selective learning fit into all of this?
This research has opened up some really exciting doors. But at the end of the day, it's up to all of us. We have to guide the development of these powerful technologies in a way that's responsible, ethical.
Yeah, we have to make sure AI is used for good.
So let's keep the conversation going. Let's question everything, explore different viewpoints, and work together to create a future where AI empowers us all, to create a better world for everyone.
Remember, the future of AI isn't written in stone. It's being written right now, and we all get to be part of that story.
So keep those knowledge-seeking brains fired up. Stay curious, and let's keep exploring this amazing world of AI together.
Thanks for joining us on this deep dive. Hope you found it, I don't know, insightful and interesting. We'll catch you next time.